Hello, welcome to Algebra 2 lesson. Before we begin our first lesson, I'd like to check a few important vocabularies. Number 1, constant. Constant is just a number. It could be positive numbers, it could be negative numbers, it could be decimals, fractions. All of those numbers we call it constant. For example, we could have a 4, negative number, negative 5, fractions, 1/2, decimals, negative 0.5. All of these numbers are examples of constant. Number 2, monomials. Monomial is a product of a constant and one or more variables, including a constant and a variable itself. So we could have constant itself, 5. This is monomial. Let's say variable x. This is also monomial. Or a product of constant and variables. Let's say 4 times x. That's monomial. Or we could have negative 2a cubed b squared. This is another example of a monomial. Number 3, similar monomial. We say that monomials are similar if they have identical variables. For example, let's say we could have 2xy squared. Here we have a variable xy squared. And let's say we have a negative 4xy squared. Here also we have xy squared, right? So we have same exact variables in these two monomials. Then we say that these two monomials are similar. Sometimes, often, we call these two monomials are like terms. Okay? Another example, let's say we have x cubed y squared. And we have 5x cubed y squared. Here, when we look at the variable x cubed y squared, x cubed y squared, same variables, right? Then they're similar monomials. Number 4, degree of a monomial. Degree of a monomial is the sum of degrees of the variables. For example, let's say we have x cubed. Then degree of this monomial is 3. And this is only variable, right? But let's say we have a monomial with 2 variables. Let's say I have negative 4a cubed b squared. Then the degree of this monomial is the sum of these two numbers right here. Sum of these 2 degrees. So degree of this monomial is 3 plus 2. That's 5. Does that make sense? Okay, number 5, polynomial. Polynomial is just a monomial or a sum of monomials. So for example, we could have x cubed minus 4x squared plus 1, right? We have 3 monomials added or subtracted together, right? This is a polynomial. Number 6, term. Term is just each monomial in a polynomial. Let's say we have polynomial x cubed minus 4x squared plus 1. So each of these monomial, we call this term. So this polynomial has 3 terms, right? Number 7, degree of a polynomial. Let's say we have a polynomial x, let me write with a black pen. Okay, let's say we have a polynomial x cubed minus 4x squared y squared plus y squared. Okay, Degree of a polynomial is highest degree of its terms. So we have 3 terms, and let's check the degree of each term. Okay, this one right here, term is 3, right? I mean, degree is 3, right? Okay, this term right here, we have degree 2 here, degree 2 here. So degree of this term or this monomial is 2 plus 2, 4, right? Degree of this term, that's 2, right? Does that make sense? So degree of this polynomial is the highest degree of its terms. So the degree of this polynomial is equal to 4 because the highest number is 4 here, right? Okay, number 8, coefficient. Coefficient is just the constant factor of each term. Let's say if we have term or monomial negative 4x squared, this negative 4 is our coefficient. Okay? Okay, in addition to this, let's talk a little bit more about polynomials. Let's say we have this polynomial x cubed. Especially this polynomial has one term, right? If we have one term, then specifically we call this is monomial. Let's say we have 2 terms, x cubed plus 5x squared. Okay, this is just a polynomial with the 2 terms. Specifically, we call this binomial. Bi means 2, right? Let's say we have polynomial with the 3 terms, x cubed plus 5x squared minus 4x. 3 terms, we say this is a polynomial with the 3 terms or trinomial. Trinomial. Let's say we have a polynomial with the 4 terms, x cubed plus 5x squared minus 4x plus 1. Then we just say this is a polynomial with 4 terms. Okay, all of these are polynomials, okay? Polynomials. But if we have more than 3, like 4 terms, 5 terms, then we just say that it's polynomial with 4 terms or polynomial with 5 terms. Okay? Using property of exponents. Let's say we have the expression a to the power of m. This a is called base, and this m is called exponent. Or sometimes we call this is the power of a. Okay, so the expression a to the m, where this exponent m is positive integer, this expression represents the product that we obtain when base a is used as a factor m times. Okay, for example, let's say we have base a to the power of 3. This means this is a times a times a. We multiply a 3 times. Law of exponents. Addition. Let's say we have the expression a to the power of m times a to the power of n. When the base are identical, all we can do is we can add these 2 exponents, just like this. Let's say we have a squared times a cubed. That is equal to a squared, that's a times a, right? A cubed, that's a times a times a, right? So 5 a's are multiplied together. Then that's going to be a to the power of 5, right? So when we have this expression a squared times a 3, a cube, all we can do is we can add these two exponents, a 2 to the 5. So that is equal to a to the 5, just like this. Let's try example number 1. The question is to simplify the expression. For number 1, we have a cubed times a to the power of 4. So that is equal to a to the 3 plus 4, right? So that's going to be a to the 7. Okay. Number 2, here we have a b times b to the power of 6 times b cubed times b squared. They all have same basis a, right? So that's going to be b to the, what we can do is we can add all of these exponents. 1 plus 6 plus 3 plus 2. So that's going to be, that's a 7. 7 plus 3, 10. 10 plus 2, that's 12, right? So that's b to the power of 12. Number 3, we have a to the power of 4 times a to the power of 5. Now, different base, b to the power of 4 times b to the 7. So we can simplify these two terms, right? Because they have same basis, a. And these two terms with the base b, right? So a to the 4 times a to the 5, that's going to be a to the 4 plus 5 times b to the 4 plus 7, right? So that's going to be a to the 9 times b to the 4 plus 7, that's 11. The question is to simplify the expression. Let's say we have a squared times a cube. This means two a's are multiplied together. And we have times a cube means 3 a's are multiplied together. So in total, we have 5 a's multiplied together. So that's going to be a to the 5, right? So when two terms with the same base are multiplied together, what we can do is we can add these two exponents. So we can actually write this expression as a to the 2 plus 3. Okay, so let's try number 1. We have a to the 5, a to the power of 5, a to the power of 7, right? So that is equal to a to the 5 plus 7, which is equal to a to the 12. Number 2, we have a cube, but this is different base, b to the 4, right? We cannot simplify these two terms, but we have a to the 5 here, a squared here. So let me rewrite this expression, a cube times a to the power of 5 times b to the power of 4 times b squared. Here, same base, same base. So that is equal to a to the 3 plus 5 times b to the 4 plus 2, right? So that is equal to a to the 8 times b to the 6. Number 3, we have two numbers with the base 2, 3 numbers with the base 5. So let's rewrite these numbers with the same basis. So we have 2 cubed times 2 to the power of 5 times 5 cubed times 5 to the power of 4 times 5 squared. So that is equal to, first, we have a same base here, right? So that's going to be 2 to the 3 plus 5 times, here we have a base 5, 5, 5. So that's going to be 5. We must add exponents, 3 plus 4 plus 2. So that's going to be 2 to the 8 times 5 to the 3 plus 4, 7, 7 plus 2, 9. Okay, number 4. We have two terms with the base A, two terms with the base B, right? So that is equal to a to the 4 times a to the x times b squared times b to the power of y. So we have a base a here. So what we have to do is we have to add exponents times b to the, same base b, right? So add exponents 2 plus y. Now we're done.